Well, hey everybody! Thank you so much for coming to my SUSECon talk, a standard and secure definition of GitOps, application as code with Fleet and Shipa. I'm Ravi Lachhman and very excited to be here speaking at SUSECon Digital 2022. So, what are we going to be talking about today in today's session? Well, first we're going to start talking about, changes in software development, how the development and delivery of software has changed over the previous several years. Then we're going to be introducing a particular term called GitOps, and also going to be layering that on with a concept called AAC, application as code, and then looking at Rancher Fleet and Shipa better together. How do we build these two particular paradigms and help you deliver applications more safely and more securely, all having a standard layer with GitOps? So let's dig in. So, a little bit about myself. I'm Ravi Lachhman. I'm the field CTO at Shipa. A little bit about myself. Prior, I was a chief architect at a continuous delivery firm called Harness. And before that, I was a distributed systems engineer at Red Hat and Mesosphere. And so I tried to stray away from Kubernetes, but it wrangled me back in. But super excited to be talking here at SUSECon. And so let's do a few things here. So let's just write some software, right? And so the going joke is, are we all YAML engineers, right? And so let's take a look at some of the lineage, some of the history of just actually how we maybe became all YAML engineers. So the first thing we want to talk about is this time period called BK, or before Kubernetes, not to be confused with Burger King. And so here, there's two people, developer, and actually on the right is Vivek, our VP of engineering, but I'll peg him as a system engineer today. So if we kind of take a look at the BK time period, as a developer, there's certain things that we need to provision. And a lot of these were statically pre-provisioned. So for example, I might need a continuous integration server, Jenkins. I might need an application server to run my app with JBoss. And I might need, let's say, a repository to store my binary artifacts, that be a JFrog or a single type Nexus. But there's something in common with all of these. All three of them were run on a virtual machine. So there's three virtual machines for your development environment. And usually each for isolation purposes, each one of these VMs are running, kind of a sole crucial workload. If you kind of take a look at the right, as we march towards production, other environments that are needed let's say we need multiple application server environments, or we need a particular web server or load balancer. Even taking a look at the F5 stack, there is that, hey, these environments were still pre-provisioned, but myself as a developer wasn't provisioning them. They were done by a system engineer or a system admin that had to go. We could fill out a ticket, and maybe there's a week of lead time before we had to deploy. And this very ticket-based IT system was there. And also, there were probably multiple syntaxes to deal with. JBoss spoke its own language, HTTPD, and ModJK spoke their own language, and they could be running in various pieces of infrastructure. Uh, so, what are development concerns in this BK time period, right? So, before Kubernetes. So, my background actually was Java. I spent a large chunk of the first half of my career as a distributed Java engineer. And typically, my workloads look like this. I would write a web application or a backend application and package that into a web archive or a WAR. There might be some Java, some J2E stuff in there, and also maybe some JMS, Java messaging services for the event-driven stuff in our applications. But we're typically going to one of three target platforms, right? Let that be a WebSphere, a WebLogic, or a JBoss. More often than not, for myself, it was JBoss. But there was a very tight coupling between the application and what was being deployed, right? The application infrastructure. And so typically, I didn't deploy. There was a release engineer, kind of doing the deployment, or a build engineer, and there was a middleware engineer who was making sure that the particular application infrastructure was there, ready to receive, let's say, the binaries that we would ship to it. But I was fairly constrained in focusing on the feature. Taking a look at today, so this is a little bit about even our stack here at Shipa that we have. Take a look at this modern software delivery that's out there. Not only did the particular language set got more granular, right, in the Java side, so there's Kafka, there's Angular, there's all sorts of things that are going on. But if we kind of take a look at items that are going from left to right, with these particular journeys that we have going left to right here, is that, hey, you know what? Not only that I have to worry about the granularity in language as a software engineer, or this full lifecycle developer concept, I have to automate the build. I have to lay the infrastructure down. We have to make containerization choices here. Let's say with Docker. Also, let's say we actually are deploying to Kubernetes. I have to make packaging, particular packaging decisions with Helm, and also we're deploying to multiple environments. We have to make overlays or customize. We also have to pick the observability stack, using Statsd or Fluentd. And then we're deploying in more than one cloud, right? We're particularly at Shippa, we're in AWS and GCP for robust system resiliency. But each one of these little journeys here is a unique or bespoke journey that there's additional syntax, there's additional expertise. And going from left to right is just providing an additional burden. And so to kind of cope with that, this whole shifting left mentality, kind of two particular practices that have been on the rise, right? So this concept of being a full lifecycle developer. So if you wrote the service, should you know the service, right? So if it's the how you operate what you build, or you run what you write, right? So it has many names, but really focusing emphasis on, oh, you wrote it, you should run it, right? Versus, the changing role of system engineer is looking like a platform engineer. He or she or that particular team kind of make sure that, hey, as a platform engineer, you make sure that the downstream or what's running the application has capacity, and you create tooling to onboard and offboard workloads from that platform. And so kind of voting that, hey, the developer or the feature author should write and run the service, providing the tooling is important, but there's a lot of knowledge gap in between, right? If you go a couple slides back, there's still a lot of movement that has to happen, a lot of skill sets you have to pick up. And so let's kind of fast forward to close to today. I call it the K era or Kubernetes era. Here is a delicious Kubernetes YAML, right, or deployment YAML. And so what Kubernetes has done is that it's kind of harmonized both sides of the table. It's harmonized the development side, and it's harmonized the operational side, right? And so a lot of operational expertise that's going into your applications, for example, if how you should scale, or what happens in case of a failure. Clearly, you should restart, right? There's a failure depending on the workload. Kubernetes allowed both people to speak the same language. So no longer is there a particular kind of a middle ground. Is no longer, oh, there's a mod JK configuration, or there's a certain syntax, or certain JSON, or a certain TCL. Pick your configuration language of choice. It's all this YAML, and as a human, you could read that. If you had zero experience with Kubernetes and you were only slightly technical, you could kind of decipher, it's like, oh, this is a deployment. Let's say the resource limits here are one particular replica set and so on. You can kind of guess if you were filling in these particular values here in this particular file, templated values here, you can kind of guess what's going on, right? But building this, like any configuration-based system, certainly has its challenges, right? And so I call it the K era challenges. So if you kind of take a look back at the purpose of being a software engineer, is that you want to focus on feature development. Like, for example, of course, I wrote a compliant feature. I scored B minus. Well, not okay, C plus. Let me give you a little break here. On our Center Cube scores, I wrote a compliant feature. I met the stylistic guidelines of the team, or I met our particular architecture standards. But no surprise, I am not a kernel engineer, right? The Linux internals to me are as foreign as maybe me speaking a foreign language. And some things that I know about the application, like, yes, I know traffic comes in and traffic comes out, but how we configure that, that's the networking decision that someone else should be making that, right? And so, and also, oddly enough, saying that, hey, Kubernetes should be an implementation detail, right? Like, running it somewhere, I shouldn't have to worry about this very, very tight coupling of where the application's running. It's like, hey, I'm running something on a virtual machine. Do I have to care if it's running on AWS or GCP or Azure? Probably not. But if something's running, running a Linux workload, like, oh, I'm running on Kubernetes, there's a lot of stuff that has to happen. And also looking at the platform of DevOps engineer to kind of facilitate this onboarding and offboarding and just managing non-functional requirements. A bunch of tools are coming in. For example, we have to have a continuous delivery stack, so we're using Argo. Again, the package manager Helm is very important. Oh, we have networking rules that we need. Here's an Istio. You know what? We have business rules and also certain policies we have to maintain. Here's OPA or Open Policy Agent. Yes, we use a scan for security. We'll use Claire or some other container or image scanning tool out there. And also, we need to capture metrics, so it's Prometheus. Like, and the tools go on and on and on. Because what ends up happening, even though everything is speaking this common, Kubernetes, let's say YAML, or maybe you're writing an operator, or maybe some Go in there, is that there's really this concept of a YAML overload, right? Like, hey, there's just a lot of YAML going on. And so instead of just having your deployment YAML, Mr. and Mrs. Developer is like, oh, hey, by the way, you know what? Can you write the networking rules in the Istio YAML? Can you create the n number of custom resource definitions that Istio, if you haven't heard of Istio, Istio is a service mesh. Can you go ahead and write that? Also, hey, write the rollout for the deployment and so on and so on. And so something that's as simple as, this turns into dozens and dozens and dozens of particular Kubernetes objects because, again, the Kubernetes by itself is fairly vanilla. But the kind of taking that challenge, right, and kind of taking a step back, it's like, okay, you know what, let's not focus on that particular challenge quite yet in this presentation. That there is still a lot of good that authoring something in YAML could give you, right? And so for another particular paradigm that's out there, if you're leveraging Kubernetes today, there's this other paradigm called GitOps. And so I'll go into a little bit of detail what GitOps is if you haven't heard about it before. And so TLDR, too long didn't read, GitOps is all about software code management, SCM hooks. Once you commit, you should go to prod, and there's a lot kind of writing there. But let's kind of unpack this particular paradigm and kind of take a look at where we sit in 2022. GitOps came from this particular academic definition came from Weaveworks, the previous Kubernetes networking firm out there, in 2017. So it's about 5 years old, but basically. And kind of not reading the whole definition there is that with GitOps, if you take a look at a software engineer, kind of when you make a commit or a merge or some other sort of SCM motion, you're actually telling the world that you're ready to start marching towards prod. So let's say I make a commit as a software engineer. I want to start kicking off the process of iteration, saying, okay, I've iterated a few times locally. I'm ready to start integrating. So let that be a dev integration branch or something that's lower in the environments. And if items pass there, you're moving upward in the environments to march towards prod. But basically, you're saying to the world, hey, it's in source code. Time is now to start executing our confidence building exercises. Do we have to iterate again? Does it make sense? If it makes sense, we should go as far as we can. And that's basically the premise of GitOps, right? And so there's these 4 pillars that Weaveworks came up with. And so let me kind of unpack these 4 pillars. And so the first thing is that everything is declarative, right? So Kubernetes is a declarative state system. And so what does that mean? So Kubernetes, if you compare the 2 types of ways of executing something, there's a declarative way and an imperative way. So usually the common thing to talk about is a pizza, right? And so, hey, you know what? I want a pepperoni pizza. You can go to your local pizza store or pizza joint and say, I would like a pepperoni pizza, and they will give you a pepperoni pizza. You didn't have to tell them step by step how to produce that. You just kind of gave what you want. Them fulfilling the work has gotten back to you. Now, Kubernetes is declarative, right? You say, hey, I want one replica, or I want one. You declare what you want. And Kubernetes, as a scheduler and a resource manager, will try to fulfill your request as much as you can. Being imperative is like you have to give every single step. Go get the flour from here, grind the flour, make it into dough, put baking soda, go find a piece of salami, make a pepperoni. The list can get very granular, like step by step, that's imperative. So everything has to be declarative, right? You have to define your end state. And also get is in the name, source code, right? So the canonical state or the state that you want is in source control. So the source of truth is in source control. One of the GitOps pillars is like, hey, if it's in source control, it happens. You go and joke here, one of my managers to Ravi up saying, hey, Ravi, if it didn't happen in Slack, it didn't happen at all, right? Or if it's not in source control, it didn't happen at all. But taking that to the system level here, the desired state is in Git. Also, like, hey, if your confidence building exercises execute, so like, oh, all of our tests passed, or it passed every piece of coverage that we had, it should be applied automatically into prod, right? And so it's like, oh, it might be as simple as kubectl apply tickf your YAML, but that's basically it, right? Like, hey, if it made sense, you should apply that change. The lengthy change management processes, it's not designed. GitOps is not designed for that. And finally, the thing that I think most people enjoy about GitOps is that there's this reconciliation or auto healing process. And so, for example, let's say in source control, I say I want one replica set. If I log into the Kubernetes cluster and I do a kubectl patch a certain resource and say, oh, you know what, I want to edit or patch something, I want to directly talking to the cluster, a GitOps engine would come and auto heal and say, oh, there's been a change or diff and what's happening in the cluster versus the desired state. Ravi, smack on the wrist. I'll let us go and reapply what was the canonical state, and it would take away two and replace that with one, right? So that's fairly interesting. But there is a little bit of a problem with GitOps, and so I like to call this a feeding problem, right? So like anything, going back to the problem set, there's a little bit of YAML overload. Like, what do you actually feed your GitOps engine, right? Like, do you give it a bunch of customized overlays? Do you have to write all this Rego and an OPA? How many Helm charts you have to feed it? How many pieces of Helm templating you have to feed? Like, the GitOps engine is only as good as what you're giving it, right? And so one of my friends made a joke, and she was like, "Oh, like the feeding problem is that the Argo mascot has a helmet on, so it can't possibly eat when you're feeding it." Jokes aside, think about that problem. You have this smooth, latest and greatest GitOps mechanisms, but still, it's like, who's authoring all of this? Who's how does this enter your pipeline? How does it exit your pipeline? And this is where application as code comes in. And so, kind of a concept I want to introduce, if you haven't heard of it before, it's something that we and a few other firms have been pushing pretty heavily. Is this concept called AAC? So the tagline, it's like Terraform, but for your apps, right? And so another going joke is that, hey, isn't all of our applications made of code? Yes, they are. That is the core definition of an application. But think about it as a harmonized, simplified way of even describing your application, right? So you don't dig into Terraform, but you say, hey, I want two EC2 instances. You don't really care how Terraform goes about and does that. Similarly, same thing with application as code. And so, kind of one of the main goals or pillars of application as code is that trying to make Kubernetes an afterthought, right? And so here's an example. As a developer, I'm able just to say, hey, I would like to deploy some sort of image, right? And replace that XXX tag with a legitimate tag. And that's it. Really looking to simplify the developer experience. That, hey, a developer hopefully should know how to build a particular image, but getting it deployed can be a little bit tricky. And that's kind of interesting, they kind of talk about saying, we built this amazing cluster management solution leveraging something like Rancher. We have n number of clusters. You can spin up and spin down nodes all day or clusters all day. But going back to that core problem is how easy is it for if you're a platform or DevOps engineer, how easy is it for one of your internal customers to put workload on your hard built clusters versus if you're a developer, same question, how easy is it for you to deploy to a cluster in your organization? And so there's a little bit of a scholastic definition of AAC, but again, kind of hammering the point home is that applications code is like Terraform, but for your applications, right? So very simply, declaratively describing what you need, and that's it, right? I want a bulletin board application that's being deployed. And so let's kind of take a look at what these pieces are. And so kind of there's just application as code focuses on these things called NFRs, right? So non-functional requirements, the facets of AAC here can be really describing your application in about 9 ways. So going back to, hey, as a developer, I know that my applications have ingress and egress. Well, that's how you also define AAC. Hey, you have traffic coming in, traffic coming out. How does that look like? Also, hey, some easy stuff. This might bleed into a little bit of platform engineering, like how do you apply a certain resource limit? Or hey, who has access to the application? Or hey, should this be security scanned? Kind of digging into a couple other facets of AAC here. It's like even a question of like, well, what is an application? As intrinsic of a question as that is it a service? Is it an image? Is it an item in your config management database? Do you subscribe to ITIL? And really taking a look at like, hey, what exactly is application? Here with AAC, we're trying to harmonize this. So like, yes, it's source code or an image. The application has to have an endpoint. Potentially has a team or a number of systems that it connects to, and also this is more Shipa specific. All this is wrapped up into a framework. And so let's talk about SUSE, Fleet, and Shipa better together, right? So let me dig into a little bit of what the logical architecture looks like here. And so Shipa is also a control plane to cluster relationship application, right? And so if you're leveraging, let's say, SUSE Rancher server, actually, we had a recent masterclass, so we dug into very great detail about how these two solutions build together. We have some collateral, always happy to send it across. Reach out to your SUSE rep. You can always get in contact. But basically, Shipa is a control plane relationship to the clusters. And so regardless if you're going to, AKS or EKS, or even here, if you're on for that logo, that's RKE, Rancher Kubernetes, right? Shipa can help facilitate deploying to that. And also with Shipa, we're actually in the SUSE Rancher cattle place. So, we have a one-click to install as you're scaling out your Kubernetes clusters. And so that's kind of the relationship there. If you take a look at, what's the next click down, is that how does this actually integrate to your SDLC, right? And so it would start from, let's say, source code management. Let there be a Git. You'll kind of go to your CI stack. It can be anything you're using to build an image, right? That can be Jenkins, Drone, Concourse, Harness. Pick your particular CI stack of choice, and then taking a look at the continuous delivery stack. Once it's in a particular Docker registry, or you have your image stored somewhere, or you can build from source. I didn't show that here. It's that, hey, you can use a GitOps solution or engine like Fleet or Argo, and basically leveraging Shipa, you can ferret out what needs to be deployed through a SUSE Rancher managed cluster. So it could be AKS, EKS, or RKE. Pick your SUSE Rancher cluster of choice, and you're able to deploy that. And so for the example here that I'm running, the first thing you have to do is pick your fleet, right? And so in our SUSE masterclass that we have, I actually use Rancher, the Rancher UI, but includes Fleet to deploy. I'll be using the Fleet by itself today, so without the Rancher server UI. So both work very similar ways, right? So there's a little bit of describing to have to go on, and then we're able to execute Fleet, and then Shipa will be deploying what Fleet says needs to be executed. Taking a look at the demo, just I'm showing a screenshot here in case the demo gods don't smile, but basically we're going to be going from a particular piece of source code or a description that's hanging out in GitHub, be using Fleet. So that's actually a screenshot of the Rancher Fleet that's inside Rancher server. I'll be using the Fleet command line by itself, and then I'm going to be deploying an application or two. So I'm going to go ahead and switch screens and actually take a look at what this example looks like. And so I actually do have a sample project that you can get to that I actually kind of lay out what the two particular pieces are here. But there are a few pieces here. The main piece would be the fleet app.yaml, right? So basically, this is a fleet definition of what we need to have. And so basically, this particular definition in Fleet is pointing to this particular repository. You can fork or clone this, and all you have to do is replace this particular address with your own. A few other moving pieces of this. Actually, another piece of integration that we have is actually we're using something called Crossplane also. So we're using Crossplane is a Kubernetes-centric infrastructure as code provider. So imagine it as the Kubernetes puppet or Kubernetes chef out there. That's actually a sort of a wrapper around Shipa. And so let me take a look at what we have here. So here I have a local version of this particular object. And actually, I'm going to be editing this particular object here. So I'm going to say, you know what? Instead of me deploying bulletin board, let me go ahead and deploy WordPress. Or actually, let's go ahead and deploy bulletin board. I think this is where the commit is. I can say, let's deploy. Actually, I'll make a modification of this really quickly. We'll deploy WordPress instead. Click commit change. That should be there. And all now that we have to do is actually run, let's kubectl, apply fleet app.yaml. And this should actually run in a few moments. And then we should actually, our SUSECon object that we have here. If you come back to Shipa, so as that's deploying, so hopefully our deployment object is running there. So as that's starting to deploy for us, Shipa will take care of those particular abstractions for us. And so let's actually take a real quick click into what a Shipa abstraction is. So going back to what exactly is a framework, going back to what actually is application as code. Here I have one called Fleet Framework, right? But basically when you're building a particular Shipa abstraction, basically there's this 9 particular prong question and answer thing that what you're actually building. So it could be like, hey, what is name of your application as code abstraction. We can figure that in general. A few other pieces are, hey, what are some resource limits to this particular application that we're deploying? Again, these are non-functional requirements that your developers don't have to fill out. Who has access to this abstraction? So you can say, hey, I might give you 8 gigabytes and 100 CPU shares. What team has access to deploy through this? Is it a production team? Is it a DevOps team? Is it a CI service? And here's some other interesting stuff. Here we have the ability to enable auto scaling with HPA. And so you might say, since we're going to Kubernetes, this won't replace something as sophisticated as a cluster level autoscaler. But for just a generic workload, again, the developer doesn't have to kind of think about, okay, like I would like another replica in case anything happens. Very simple to configure that. Version control, if you're pulling from certain, let's say, Docker registries, if you're on AWS, you might pull from your account, ecr.aws.com, making sure that you have, let's say, golden or certified images there. Application control, these are taint and toleration, so node selectors written for you. My favorite piece here is actually this thing called a network policy. So my biggest personal outage, I misconfigured a Kubernetes networking policy. I'm not good at networking. My background's in Java. With Shipa, we have the ability to abstract that away, right? So you could easily, in plain English, talk about, hey, we're SUSE.com. Go ahead and allow all the traffic, and then SUSE.com could only talk to, let's say, SUSE.com/login, right? Or authentication or authorization service, kind of wrapping up what AAC is. Like, oh, yes, we just scan our applications until you can kind of bundle that together. Some newer stuff. These are the other last two are kind of very Shipa specific, so I'll kind of hold off for there. But if we kind of take a look at the event here, looks like we just had success. Hopefully our example has deployed correctly. So if I come back to the application, back to Fleet app, and I go to this particular address that was executed by Shipa, hopefully we'll be able to see WordPress come up. So fingers crossed for the demo gods here. There we go. So WordPress came up as simply as coming in and changing the image name here. So going back to all we had to provide from a developer experience is the abstraction and the image that we had to deploy through an execution object with Fleet as the GitOps execution engine. We were able to deploy that. And so I'm very quickly able to kind of take a look at the running application here. But that's all I had for my SUSECon session. Very excited to be talking to everybody today. I hope to stay in contact. If you have any questions, feel free to hit me up. And until next time, cheers, Ravi.